All right. Good afternoon, everyone. Welcome to our webinar, and thank you for joining with us today. My name is Richa Mishra, and I'll be your co-host for this informative session. So today we have come up with the topic of Kubernetes Canary Deployment and how powerful and managed it can be when coupled with Istio Service Mesh. But before deep diving into the topic, let me tell you that this session will be recorded for the future references. And secondly, if you have any questions during the presentation, please make a note of it, as we have set the dedicated time for the Q&A session at the end of the webinar. So having said that, please allow me to introduce to our presenters, that is Ms. Neha Chalia, Ms. Shikha Atri, and Mr. Rohit Sharma. So I will request Ms. Neha Chalia to please take over the stage and share your expertise with us. Neha, over to you. Thank you.
Good afternoon, everyone. Let me share my screen. My screen is visible?
Yes, Ms. Neha.
So, warm good afternoon to everyone. And I'm Neha Chalia. I'm with my colleague Shikha Atri and Rohit Sharma. We are going to present a webinar on Kubernetes Canary Deployment using Istio Service Mesh. So, in agenda, we will be going to discuss some brief about microservices architecture, containers and orchestration, Kubernetes deployment strategies, and along with focus on Canary deployment with demo part and followed by Q&A. So this is about us. I'm Neha Jalia, my colleague Shikha Atri, my colleague Rohit Sharma. We are cloud DevOps engineer. So let's talk about the rise of microservices architecture. The evolution from monolithic applications to microservices architecture reflects a significant transformation in the way software applications are designed and deployed. So traditionally, software applications were built as monolithic, where all the functionality of the application resided in a single code base and was tightly integrated. Monolithic applications were easier to develop initially, but became complex and challenging to maintain and scale as they grew in size and complexity. Then came our transition from monolithic to microservices. For this, the need for more agile and scalable and maintainable systems led to the emergence of microservices architecture. Organizations began breaking down monolithic applications into smaller, independently deployable services, and each responsible for a specific functionality, or you can say the business capability. Now, microservices allowed for faster deployment cycles and improved scalability and easier maintenance. And with microservices, applications changed dramatically. They became distributed systems with multiple services and also with communicating over networks, and also embraced continuous integration and continuous deployment practices. Now, splitting monolithic application to microservices solved many of the traditional problems like deployment, scaling, faster time to market, but transitioning to monolithic came with its own challenges. Now, we have to deal with how to manage dependencies across multiple microservices. For example, any application may have dependency on Java as well as with DB. So you need to think about how those dependencies will be managed. For a larger enterprise applications, there could be more than 100 microservices. So you need to take care how these microservices will securely connect with each other. And then the another challenge could be deploying microservices across various environments, such as development, testing, staging, and production, present its own set of challenges like environment consistency, scalability, and configuration management. Imagine you have more than 100 microservices and say 5 to 6 environments. You can imagine how difficult it would be. Now, the solution is containers. Containers is a technology that allows applications and their dependencies to be packed together in a consistent and isolated environment that are known as containers. And basically, they provide a isolated or they are lightweight and portable way to run software applications across different computing environments, such as development, testing, and production without worrying about differences in underlying infrastructure. Now, the problem is resolved. Containerization basically addressed many challenges in microservices, and they package applications and their dependencies, ensuring consistency across environments. And they also offers isolation, allowing microservices to run independently without any interference. Also, they are highly portable, so making it easy to move microservices between environments or cloud providers. Now, we have been splitting monolithic microservices and containerization of microservices solve all our issues and challenges. You must be wondering, what next? So, is that all we have to do to manage microservices? Well, no, you have to think about that. So, what next? You have the question arises how to run containers in production system, how to scale containers, how to manage networking in containers, and how to manage security of containers. Now there comes container orchestration. Container orchestration basically is the process of automating the operational effort that's required to run containerized workloads and services. Also, it automates various aspects of the containers lifecycle. Glitch. Yes. Container orchestration is basically the process of automating the operational effort required to run containerized workloads and services. Also, it automates various aspects of the containers lifecycle, including provisioning, deployment, scaling, networking, load balancing, and traffic routing. Now, the question arises, how container orchestration helps? Deploying manage large number of containers, scale containers up or down as needed, and ensure that the containers are running in the correct environment and with correct resources. Monitor containers and take corrective actions if necessary, and provide high availability for containerized applications. Now, there are some container orchestration platforms, and some of them are Kubernetes, OpenShift, Docker Swarm, HashiCorp Nomad, and Apache Mesos, and Ranger. So, Kubernetes is the most popular container orchestration platform, and that automates the deployment, scaling, and management of containerized applications. And it was originally developed by Google and is now maintained by Cloud Native Founding Computing Foundation, that is CNCF. Some of the features Kubernetes have, like self-healing. Self-healing, like Kubernetes continuously monitors the health of your applications by automatically restarts and replaces failed containers. Second one feature is the automated rollback. It supports rolling updates, which allows you to update your applications without downtime and by gradually replacing old containers with the new ones. Third feature is auto scaling. It automatically manages the deployment of containers and ensuring that a specified number of replicas are running and scaling them up or down as needed. And the last feature I can say that is the load balancing. It also includes this mechanism to distribute traffic across different instances of a service. So now let's talk about how we deploy applications on Kubernetes cluster using different deployment strategies. First one I'm going to explain is a recreate deployment strategy. As the name suggests, in this deployment strategy, we stop the running application and then deploy the newer version and then start the application. Since in this strategy, we stop the older version, and this technique creates a system downtime between shutting down the older version and of the application and booting the new version. So there are some challenges of using recreate deployment, like first one is unavailability of applications. The significant drawback of recreate strategy is significant downtime during the update. Since I can say that old ports are terminated before the new ones are created, and there might be a period during which application is unavailable to users. So this is one of the challenge of using a recreate deployment strategy. Another challenge is inconsistent user experience. Depending upon the nature of your application and the update frequency, users might experience disruptions or service degradation during that transition period. The next deployment strategy I'm going to explain is the rolling deployment strategy. Is this strategy that slowly replaces previous versions of an application with new versions of an application by completely replacing the infrastructure on which it is running. And this is the most commonly used or default deployment strategy when it comes to Kubernetes world. But there are also some challenges associated with it. The first one is the rollout, rollback can take time. Kubernetes rolling deployments involve updating pods incrementally. And while this helps maintain application availability, and the process can take time, especially if you have a large number of pods. So during the rollout, there might be a periods where when both old and new versions are running, potentially affecting the overall update duration. Second challenge is there, like no control over traffic means rolling deployments offer limited control over traffic redirection. And while Kubernetes automatically distributes traffic between old and new pods, this might not be sufficient for all scenarios. Strategies like blue-green or canary deployments provide finer control over traffic routing and allows you to gradually shift traffic to the new one. Next deployment strategy is blue-green, and in this we create another set of server group identical to live environment, and newer version is deployed to the newer server group, and which is live to the end users. And once testing results are satisfied, then traffic is switched for end users from older version to the newer server groups. But there are also some challenges. Like first one is the downtime. In downtime, I can say that there is still a risk of downtime during the deployment process, and as traffic is switched between the two environments. So it's one of the challenge. And the second is cost. Like blue-green deployment requires two identical environments, which can be expensive to maintain. So cost is another challenge of using blue-green deployment strategy. Next strategy is canary deployment. Canary deployment is similar to blue-green. The only difference is in blue-green, we switch the traffic from older version to newer version in one go. But if I talk about canary deployment, we switch the traffic from older version to newer version incrementally. This will help to reduce the risk of deploying faulty version to all users. Now, the working of canary deployment. So let's see how the canary deployment works. We do have an application version V1 running on production deployment. We have to deploy another version of the same application, let's say version V2. Now, canary deployment will gradually increasing the traffic from the older version of application V1 to newer version V2, and we have just routed 10% of traffic to V2. And once we are fully satisfied to version V2, we can completely route all the traffic to V2. Now, there are some benefits of using it, why we have used it. Like first is zero production downtime. A small subset of users or traffic is directed to the new version of your application, while a majority continues to use the old version. And this step-by-step process helps catch potential problems early, making it possible to achieve zero production downtime. Second benefit is faster rollback, means it quickly reverting to previous versions if any issues arise, and ensures minimal impact on users by shifting traffic away from the new version. Third benefit is improved user experience. Like it ensures, Canary ensures a smoother transition for users by addressing issues before they impact a larger audience. And this helps to maintain a positive user experience during that update process. Fourth benefit, I can say that the flexibility for business to experiment with new features. Like Canary deployment provides businesses the flexibility to test new features with a small group of users before full release. And the last one is the feedback. Here, the testing, I can say the new version with real users allow you to get the valuable feedback and insights. And in that, helping you to make informed decisions about the version's readiness for a wider release. Now, all of you can see that in this recreate and Kubernetes supports recreate and rolling deployment strategies out of the box, but not support blue, green, and canary. So here, Istio Service Mesh comes into the picture. Istio is basically an open source service mesh that helps manage and secure microservices based applications. Also, this is a dedicated infrastructure that provides various features to facilitate communication or observability and security within or between microservices within a distributed application. And Istio was developed as a joint project by Google, IBM, and Lyft, and has gained popularity in the Kubernetes ecosystem. It was started in May 2017 and was developed in Go. So other than the deployment challenges we are trying to solve, Istio can help in these aspects also. It can help in traffic management and load balancing, observability and monitoring, security, fault injection, and resilience testing. Now, how to perform Kubernetes Canary deployment with Istio? We need to have a Kubernetes cluster with Istio and Canary. So I'm handing over the demo part to my colleague Rohit. Rohit, over to you. Thank you.
Thank you, Neha. So before going to the demo part, first we will go for the prerequisites. So let me share screen. So in prerequisites, first we need the Kubernetes cluster of version 1.24 or above. Then we need Istio of version 1.18, that is the latest version. Then we need two Docker images, the sample app for the Docker images. The current version is V1 and the new version or the Canary version is V2. Then we need the container registry for Docker images. Now we will move for the demo. These are the prerequisites. So in this demo, I will be deploying a sample app on Kubernetes cluster. Then we will show deployment of same application with upgraded version using Canary deployment strategy. We have created an AWS EKS cluster, and we have also built images of Python application like V1 image for current version and V2 image for newer version or Canary version, and push these images to Amazon ACR. You can also create the Docker images and push to Docker Hub also. It's up to you. So we have already logged in into EKS cluster, and we have installed the Istio on the top of EKS cluster. So now we have the deployment manifest file here. Let me show you. In this deployment manifest file, we have namespace file, deployment file, service file, gateway file, and virtual service file. So let's go in brief about these. So first we have the namespace file. So in this section, namespace section creates a Kubernetes namespace named Canary deployment and applies a label Istio injection enabled. This label indicates that Istio's automatic sidecar injection should be enabled for pods deployed within this namespace. Now we have the deployment file. In this section, this deployment section defines a Kubernetes deployment named demo app v1 within the candidate deployment namespace. It specifies that a single replica of the application should be deployed. The selector field ensures that pods created by this deployment have labels matching a demo app and version v1. And the template section within the deployment defines the pod template for the deployment. It sets labels for the pod, and the containers section specifies the Docker images to be used. And the container port is listening on the port 5000. Now we have the service file. This section defines a Kubernetes service named demo app within the Canary deployment namespace. The service is used to expose the application internally within the cluster. The service is cluster ID, as you know. It forwards traffic from port 80 to the target port 5000 of the ports with the label app demo app. Now we have the gateway file. The gateway file section defines an Istio gateway named demo app gateway within the Canary Deployment namespace. The gateway is used to configure how external traffic enters the Istio Service Mesh. In this case, it listens on the port 80 and is associated with the host canarydeployment.test.cloudtechnet.com. The host name is used by us, canarydeployment.cloudtechnet.com. You can use your host name also. Now we at last we have the virtual service file. So in virtual service file, in this section, uh, it defines an Istio virtual service named demo app virtual service within the Canary deployment namespace. The virtual service configures the routing of traffic within the Istio service mesh. It specifies that traffic from that defined host should be routed to the demo app service using the host internal DNS name or domain name. Now apply the deployment.manifest.yaml file. For that, we have to type kubectl apply -f deployment manifest.yaml. So you can see here that namespace, deployment, service, gateway, and virtual service is created. Now check for the ports and services. kubectl get all -n and namespace name is canary -deployment. So here you can see the port demo app v1 is deployed and it is ready. You can also see the service cluster IP deployment. It is also ready, and the replica set 1 that is desired and current is 1. So now we will go for the kubectl get svc -a. You can also type kubectl get all -a. So here we will get the load balancer CNAME. Here you can see the load balancer CNAME. So you have to map this your load balancer CNAME with your domain name or host name. As you know that I have already told you that in that case we have our host name or domain name, that is canarydeployment.test.cloudtechnet.com. So you have to map this load balancer CNAME with your domain name. Now use this host name on the browser to access the application of version v1. So we will go for that. So here you can see the version v1 which is deployed. So we have seen a sample application running on Kubernetes cluster. Now my colleague Shikha will show deployment of same application with upgraded version using Canary deployment strategy. Over to you, Shikha. Thank you.
Thank you, Rohit. So let me share my screen first. So yeah, so we as you have seen the version V1 application is running on the Kubernetes. Now we are upgrading the same application to the newer version, let's say version v2. So we have also created a manifest file name as canary-deployment-manifest.yaml. So in this we define 3 sections, where first section is for the deployment, second is for the destination rule, and third one is for virtual service. So let's check out all these sections. So the first section is for the deployment. So the deployment section defines the Kubernetes deployment name demo app v2 within the Canary deployment namespace. It specified that the single replica of the application version v2 should be deployed, and the match label selector ensure that this deployment targets the pods with the label app demo app and the version v2. The template section shown that it defines the pod template, and the container within the pod is pulled from this Docker image canary-istio-demo v2 and specify that the port 5000 is exported for the communication. So the second section is for the destination rule, and the destination rule name demo app within the namespace canary-deployment. So we have created two subset name v1 and v2 with their version v1 and v2. This is necessary for Istio traffic routing to know where to send the request based on the subset. And the last section is for the virtual service. So the virtual service name demo app hyphen virtual service within the same namespace canary deployment and it also targets the gateway demo app hyphen gateway within the host name canary hyphen deployment.test.cloudtechner.com. So we have created two routes, or you can say we have set up two routes. The first route sends 80% of the traffic to the version v1 subset with weight 80 as you shown of the demo service, and the second route send 20% of the traffic to the subset v2 with weight 20 of the demo app service. This setup is for canary deployment where 80% traffic goes to the existing version v1 application and 20% to the newer version v2 to gradually test the new version with the portion of users. This allows you to gradually shift traffic to the newer version v2 while monitoring its performance. So let's just apply this manifest file. So you need to type kubectl apply -f canary-deployment-manifest.yaml. So as you can see that deployment, a destination rule and virtual service has been created. So let's check what are the resources has been created. Get all in the namespace canary-deployment. As you can see, the demo f-v2 pod is created and it's running, and also deployment and the replicas also created with one. So let's check locally as well. For locally, to test the canary, so we have divided the traffic, user traffic, so that the 80% of users are exposed to the stable version, which is the version 1, and the 20% of users are showed to the version v2. As you can see, the ratio are in 80 and 20, so the version 1 is showing, the portion of version 1 is greater than the version 1 v2. Once we are satisfied with the result of the behavior of the newer application version of the smaller set user, we can gradually increase the version traffic of version v2 by increasing the weight parameter for v2 and reducing the weight parameter for v1. So let's check on the Kiali as well if the traffic is switched or not. So as you can see here in this, the 79.1% is showing to traffic showing to the v1 and 21% is showing to v2. So let's again add it in the canary -deployment -manifest file and change the weight parameter for V1 from 80 to 50 and for the V2 version from 20 to 50. So you need to again save it and apply again. Now you can see that the virtual service is configured. So that means the 50-50, so that means that the both version has same ratio with 50-50. So that means half of the user will expose to the version 1 and half of the user will expose to the V2. So let's check again locally. Here you can see the ratio are in same as we routed to 50-50%. So let's check again on the Kiali as well. As you can see here in the weight is decreasing for the V2 and the weight is increasing for V1. Now you can see the 50-50% for both versions. Once again, if we are satisfied with this testing and result and the behavior of the newly deployed version, so then you need to move again, and now we are ready to shift all the traffic to the version 2. For that we need to update in the canary -deployment -manifest.yaml file. So you need to shift all the traffic to V2. So that means you need to give the weight 100 to V2 and 0 for V1. That means all the traffic will be routed to V2. So again, you need to save it file and you need to again redeploy. So once again, the virtual service is configured. Let's check it locally. Here now you can see that the version 2 is showing. That means all the traffic is routed to the version 2. So let's check on the Kiali as well if all the traffic is switched to the version 2 V2 or not. Here you can see that the traffic is increasing for the V2. So it's take time to reflect the value, basically for few seconds. Once the application is fully switched to the version 2, we can reduce the number of replicas for the version 1 to 0 to save the resources. So now we are reducing the number of replicas for the version 1 to 0 to save resources. For we need to type kubectl scale deployment demo app -v1 in the namespace canary -deployment replicas equal to 0. Sorry, I just skipped the E part in the scale. Yes, you can see the demo app -v1 is scale. So let's check if there is a pod is running or not. Now you can see here that only the demo app -v2 is showing, the pod v2 is showing and running, and you can see here the deployment and the replicas are scaled down to 0. So let's check the Kiali. So you can see here that the all the traffic is routed to V2 and and we scale down the V1. So in few seconds, the V1 also remove from here. So in this demo, we saw that how we upgraded a newer version of the demo app using Kubernetes and Istio and tested it using Canary deployment strategy before rolling out to all the users. That's all for the demo perspective. Thank you.